In today's Daily Dose of Math, the student has been given a table of values. Title is Number of Cherry Tomatoes Produced as a Function of Age of Plant. Age is in the X column and number of tomatoes is in the Y column. Age is measured in days. This is a secondary for statistics task question. One of the bigger questions where there's some flexibility in how the student solves it, but they have to analyze the situation. They have to answer the question using all of the appropriate tools from their course. They are asked, is a linear or a quadratic model more appropriate to explain this data? And if x equals 80, that is, if a tomato plant is 80 days old, how many tomatoes is it likely to produce using each model? So the student has to produce both the linear and the quadratic models and answer the question with both. But then the student also has to decide which model better reflects the data. I've already done the answer, which I have been hiding behind these props. I have the linear part of the answer on the chalkboard, and I have the quadratic part of the answer on the whiteboard. Up here is a scatter plot. This is the first thing that I think a student should do when they're answering a question like this. Graph it in a scatter plot. Remember to label your graph correctly. And use the plot as part of your answer when you're deciding which model best fits the data. This is analyzing the situation. And when the student does that, they're earning marks, and if it's an exam question. There are many different methods that can be used to find R values and equations in both linear and quadratic. In this case, I use the calculator. It's one of the allowed methods. The linear equation that my calculator gave me is y equals 0.8934x minus 15.2118. Round the a and the b to 4 places in order to preserve more exactness in your answers. The R value that I got is 0.95. Applying the table that comes with my course, the student uses to judge an R value. Because 0.95 is less than or equal to the absolute value of our R value, which is less than 1, that means we have a very strong correlation, and the student has to judge it and say so and give the line from the table as justification. And because it's linear, the student also has to say whether the correlation is positive or negative. In this case, it's positive. Even if the student thinks that's obvious, you still have to say it. Then the student plugs x equals 80 into the equation and solves for y, in this case getting 56.3 tomatoes. Don't forget the unit of measure. That's tomatoes. The student also has to find an equation for the quadratic model. Again, I used the calculator for this, and I got y equals negative 0.0088x squared plus 1.7169x minus 33.7106. That's my A, my B, and my C. And the R value is 0.97, which, using the same line from the table, still gives us a very strong correlation. We don't bother saying positive or negative in the case of quadratic. When we plug in x equals 80 days into that equation, we get y equals 47.3 tomatoes. Now we've answered the question with both models, but we haven't said which is the better model in this case. To do that, I recommend that the student not only use the R values, but also use the shape of the scatter plot. Use both, even if you think the R value is so much better in one than the other that it makes it a no-brainer which model you want to choose, you still need to talk about the scatter plot. The quadratic is better in this case because R is higher, although it's not very much higher, and the curve looks more like a parabola than a line. And this student, the last thing I'm asking the student to do when they're answering a question like this is to show me the parabola that you see in this data. And show me the line you see. This is how we approach the type of task question where we are asked, Does the data seem to fit better a linear or quadratic model? And we are given an x value in this case to plug into the equations to give us a y value. One note is the numbers that I'm getting from my a, b, and c here and for the a and the b in the linear will be different if you use a different method. So long as you're using one of the approved methods for finding the a, b, c, and r for the two models, it's okay if the numbers that you get aren't exactly the same as the numbers that are gotten by someone who used a different method. That is today's Daily Dose of Math. Please like, subscribe, and share.